This is Lesson 5.9, Part B. Now we're going to talk about equations with imaginary solutions. In solving this step right here, we would subtract 20 and get 5y squared equals negative 20 divided by 5y squared equals negative 4. We'll square root both sides to undo the square. And our answer will be y equals, we have a square root of a negative number, which means you will have an I. The square root of 4 is 2. And you must remember something very important, and that is that if we are solving with an equation that has a square in it and we square root to undo it, our answer will be plus minus. Very important, this is easily forgotten. So plus minus 2i. Now, letter E is unique to the book. It's not a very difficult question, but it does take some explaining to make sure you know exactly what they're asking you to do. A complex number is a number that has a real part and an imaginary part. The real part has no I, and the imaginary part does. Any number can be written as a complex number. For example, the number 2 is a complex number where 2 is the real part and there is no imaginary part. So you could write it that way to put it in standard complex form. Or I could give you 2i, which is a imaginary number that has a 0 part for the real part. Both are considered complex numbers, and any number can be written as a complex number. So in this question, they're saying if 2x represents the real part, how can it equal negative 14? In other words, 2x equals negative 14. How is that possible? Well, if you solve for x, to make this work, x would have to be negative 7. The imaginary part would be looked at as y to the I equals negative 3i. What must y be for this to be true? Well, if you want to do it longhand, you can solve for it by dividing by I and get negative 3. Those two numbers for x and y would make this a true statement. The nice thing about complex numbers is they go by basically the same rules that we would have if we had radicals. Like terms go together when we're adding and subtracting. So here we have the real parts being added together, which would give us 5. We have the imaginary parts that would be added together, and there's 5i minus 4i, which will give you I. So 5 plus I is the result. When there's a negative, be careful. It means we have to distribute. So negative 1 times 3 is a negative 3. Negative 1 times a negative 7i is positive 7i. Now we're back to where we were before. Real pieces get added together, which is 1. Imaginary parts get added together, which is a positive 1i, or just I. 1 plus I. Multiplication is, again, a FOIL process. So if we FOIL this, first times first gives us 7. Outside gives us negative 5i. Inside gives us plus 21i. And last gives us negative 15i squared. these are considered like terms, so that is a positive 16i, and I squared is equal to a negative 1, so this will become plus 15. Again, we have like terms. That is 22 plus 16i. The last two pieces are complex fractions, or not complex fractions, but we have fractions that need to be rationalized. I is considered a root of a negative number, so that is inappropriate. To handle this, we'll go back to a familiar method of multiplying by conjugates. Conjugates is just changing the middle sign. So we will FOIL the bottom, and if they are conjugates, remember, out of the FOIL process, we do not need to do the outside and inside because they will cancel if they are conjugates. So I only need to do the first and the last. And that will give us a negative 4i squared, which is the same as a negative 4 times a negative 1, so plus 4, which is 13. This is in the bottom. On the top, we will have 15i minus 10i squared, which will become plus 10 because I squared is equal to a negative 1, and negative 10 times negative 1 is positive 10. So I will put this in appropriate notation. So the real term first, imaginary part second, over 13. Now this is an okay way to write your answer. Sometimes the book will split it up even further and say we want a real part written separate from an imaginary part. Both of these are correct. Nice thing about B is that all we need to do to take care of this is multiply top and bottom by I. There is no addition and subtraction going on in the denominator, so I should take care of business. This will give us 5i squared in the bottom. And that's equal to a negative 5. On the top, we have to distribute. So we'll get 4i minus I squared. I squared is equal to a negative 1. So this becomes 4i plus 1. And I would rewrite that as 1 plus 4i. Again, finished form would not have the negative in the denominator. They would either write it this way, with the negative in front, or put it in the numerator, which would be negative 1 minus 4i over 5. And then you'd want to separate them. So if negative 1/5 is the real part, and 4/5 I is the imaginary part. And that does it for lesson 5-9.